Hello everybody, welcome back to math class. We're talking about the factor form of quadratic functions today. We've done a few days of factoring quadratics, and I told you that there was a point to this, and this is where the point comes in. Okay, so let's do some quick review. So quadratics. Any quadratic equation can be written in standard form of a quadratic of a squared plus bx plus c. That's what you see over here. So section. This is what our quadratics usually look like. They don't have to look like that, but they can look like that. Okay. You also might not have an equal 0. You could have, say, y is equal to 2x squared plus 5x plus 2. That is a perfectly valid quadratic. Okay. So yeah, that's what a quadratic function is. Okay. Function or equation. For the purposes of our class, it doesn't really matter. So we're not that concerned with hold on a second. We're not that concerned with the wording. We're just saying that it's a quadratic and that we can solve them. Okay. So there is a way of solving a quadratic using factoring. Remember, when we say solving, it means to find the zeros or the roots or the x-intercepts. Those all mean the same thing. Okay. So when we say solve, it means to find the x-intercept. Okay. And we use something called the zero product theorem, this part right there, zero product theorem, to extract the roots or to find the x-intercepts. Okay. What is the zero product theorem? So the zero product theorem says if a times b is equal to 0, then either a is equal to 0 or b is equal to 0. Okay. Think about it like this. Let's say I have 2 times 3. Okay. That's equal to 6. If you look at the multiplication table, go through all the multiples of 2, you'll find that there's no way to get a 0 out of it, except by using one number, which is 0. So 2 times 0 gives you 0. And if you do this for every number, you'll realize that in order to get an answer of 0, you always have to multiply by 0. Okay. So the only way you could possibly get 0, let's say I have, I don't know, let's just make up a number. Let's say I have 93 times blank. I don't know what this blank is, but I do know my answer is 0. Okay. If you try this, you'll realize that the only number that could cause this is 0. The only way to get a 0 is to multiply by 0. So if I told you that I have two numbers which I don't know, one of them is A, one of them is B, I don't know what numbers they actually are, but I do know that I have two numbers, and if I multiply them, I get 0. You don't know what A and B are, but you know that at least one of them has to be 0. Could be both, but at least one of them has to be 0. Because if it's not 0, then there's no possible way your answer could be 0. That's basically what the zero product theorem says. Okay. So if you know that A and B equals 0, then at least one of them has to be 0. Okay. We're going to use that for quadratics, because what that means is if we can factor our quadratics so that it becomes what we call the factored form, and we set that quadratic equation equal to 0, then we can use that to find the x-intercepts or the roots. Okay. So, for example, if you have a quadratic like this, there's a slight typo here. Please fix this for me. The first bracket is x plus 5, and the second bracket, this is supposed to be a 2 right here. So please cross that out and put a 2 over there. Okay. So if x plus 5 times x minus 2, remember, if you have two brackets next to each other, right here, there's understood to be a multiply. Okay, so there's a little multiply symbol right there. You use a dot to represent multiply. This means that either x plus 5 is equal to 0, so either your first bracket is 0, or your second bracket of x minus 2 is 0. Okay. And to make this 0, well, if you have x plus 5 is equal to 0, what does x have to be? Well, x has to be negative 5, because negative 5 plus 5 is the only way you can get 0 out of that. Okay. So that's how you get x equals negative 5 over here. On the other side, you've got x minus 2 is equal to 0. Well, what does x have to be? Well, to get minus 2 equals 0, it has to be a 2. 2 minus 2 equals 0, which is why we have x equals 2 over there. Okay. So this is how we solve our quadratic and find our x-intercepts. Okay. The last thing to pay attention to is over here. you have a what's called a factored form of a quadratic right here. Oh, my pen's not writing for some reason. Here we go. You have a factored form of a quadratic, and it looks like this. Y is equal to a bracket x minus r, close bracket, and then another bracket x minus x minus s, close bracket. Okay. So here, your r and your s values actually become your x-intercepts. Okay, so let's have a look at what this actually means in terms of graphing and then using it to find the x-intercepts. So let's look at example 1. Sketch the following, sketch the graph of this function here. So we have y is equal to 2x squared plus 12x plus 10. State the domain and range of the function. Okay. So we're going to do this by factoring. So we're going to go factor this. Y is equal to 2x squared plus 12x plus 10. If you look at the factoring flowchart that we looked at last week, the first thing you should do is you should find a common factor in this quadratic. We have 3 terms, and there is a common factor between them. The common factor is a 2, so I'm going to factor that out. Okay. And we end up with x squared plus 6x plus 5. And now what I do is I factor the trinomial inside that bracket. And to do that, we're going to find the factors of 5 that adds up to give you positive 6. So I'm going to change colors. I'm going to do it on the side here. Factors of 5 are 1, 5, negative 1, negative 5, and that is it. That's all I got. Okay. So which one works? It's the 1, 5 that works, which means my factors look like this. X plus 1, x plus 5. Okay, so this is my factored form. Okay. Once I get here, what I do is I turn the y equals into a 0 equals. I'm trying to solve for the x-intercepts by doing this. So I'm going to say, okay, this is 0 is equal to 2 times x plus 1 times x plus 5. Okay. So once you get to this point, you'll realize that 2 doesn't matter, because I can just divide everything by 2. I can be like, I'm going to divide all this by 2, and then divide this by 2. Okay. So these 2's will cancel out, but what happens on the left side? 0 divided by 2 is still 0. Nothing changes. 0. Okay. And I have my brackets of x plus 1 and x plus 5. That 0 doesn't do any, sorry, not the 0. The 2 that I just canceled out doesn't do anything now. It's going to do something later. Okay, so this is where the 0 theorem comes in. I have 0 is equal to 2 brackets here. These 2 brackets are being multiplied by each other. When you have situations like this, that means either this part is equal to 0 or this part is equal to 0, and you have to do them both. So let's do them both right now. Let's do this part in green. Okay. And what happens is you say, okay, well, 0 is equal to x plus 1. Well, what does x have to be in that case? Well, x has to be negative 1. That's the only number that works. If you have negative 1 plus 1, that gives you a 0. So this gives you one of your x-intercepts. Let's go do the other one. Let's use purple this time. If I'm doing this guy, I have 0 is equal to x plus 5. So what does x have to be? Well, x has to be negative 5. So these become my x-intercepts. I have x-intercepts at negative 1 and negative 5. So I'm going to go graph it on my, I'm going to go find it on my graph here. Negative 1 is over here. This is my 0 right there. And you can see it goes 1, 2, 3, 4, 5. This is negative 5. I actually need that point, so let's put it over here. Here's my negative 5. Okay. X equals negative 1 would end up over here. So there's my 2 x-intercepts. Okay. I know because my first number here is positive. If I look at my equation, this first number is 2x squared. That's a positive number. So I know I'm going to get a smiley face like this. And so my graph's going to come down like this in some way. But I can't just throw it like that. I need to actually go find the vertex. Okay. What is my vertex? Well, going way back, when we first started the quadratic unit, I told you that if you have this two of the same y values, your vertex is in the middle of those two. Okay? And it's because your graph has to be symmetrical on both sides. My graph has to look like this. Okay? My two sides have to look identical. So that means my vertex has to be right in the middle of these 2 points. Okay? Where is that? Well, my 2 points are at -1 and 5, -5, sorry. So this has 1, 2, 3, 4 steps to go over, which means my vertex is going to be in the middle along this dotted line here, which, by the way, that dotted line is my axis of symmetry. So this axis of symmetry is y is equal to -3. Not particularly important, but I just need the -3 part. Okay. So my vertex is going to occur at x equals -3. Okay, that's all fun and good, but that doesn't tell me where the vertex actually is. Okay. So what I have to do is I have to take this x equals -3, plug it back into the equation, and go find the y value. So y is equal to 2 times -3 squared plus 12 times -3 plus 10. You really have to watch your negatives when it comes to these guys. Okay. So first step, I have to square this. -3 squared is a 9. 9 times 2 is 18. So the first term is 18. 12 times -3, that's a negative number. 12 times 3 is 36. And then I have a plus 10. So 18 minus 36 plus 10, that's going to be, what's that? That is -8, I think. Double check. Yep, that is -8. Cool. So my vertex is at -3, -8. Okay. Now I can go graph it on my graph here. -3 is on this dotted line. -8 is 2, 4, 6, 8 is over here. So it's that dot there. And with those 3 dots, I can construct a rough sketch of what my graph looks like. It looks kind of like this. Here we go. And finally, I can state the domain and range of this function. Okay. The domain is easy. Domain is always the same. X in the set of real numbers. Unless otherwise stated, or if I give you a word problem, it's always this one. Okay. What is the range? Well, range starts off the same. Y is in the range of real numbers. Also, y has a minimum here. The minimum is -8. So y has to be bigger than or equal to -8. Okay. So I've sketched the graph of the function, and I've used my vertex to determine my domain and range. Okay. So let's look at the steps here. Just going to label the steps here. Step 1, we factor this stuff. Okay. Step 2 is over here, this section, where we took our factored version and found our x-intercepts. Find x-int. Step number 3, I use my 2 x-intercepts to go find my vertex through the axis of symmetry. Okay? Because remember, my vertex has to be in the middle of my 2 x-intercepts. So use that to find vertex. Okay? When I say find vertex, you also have to find the y value of the vertex, which is what we did over here. And then lastly, state answer from there. So that's the process for this question. Okay, so let's flip to the back. We're going to do another example. Here we go. Let's have a look at this. So this one, we have a negative value for a squared. So before we even start, we should say, hey, that's a negative. That means our graph is going to look like this. It's going to be a frowny face. That's fine though. Just because it's a frowny face doesn't mean we have to be sad. It just means it's a frowny face. We can't find a common factor to start that. Okay. So we're just going to go in and factor it. So here my factor is plus 15 at the end. I'm looking for factors of 15 that adds up to -2. Okay. So what are the factors of 15? I've got 1, 15, negative 1, negative 15. Does that work? It does not. I've also got 3 and 5, negative 3, negative 5. Oh, actually, no, I screwed up something. I messed up. I forgot to multiply A and C together. If you look at the flowchart on the factoring, you'll remember that I told you to multiply AC for your magic number. So AC here, my A is a negative 1, that's this one over here, times that 15. So my magic number is actually negative 15, not positive 15. Okay. Then you go find the factors. So my factors are negative 1, 15, 1, negative 15. Neither of those two work. I'll have negative 3 and 5. Does this one work? This one does not. I have 3, negative 5. Does this work? This one does work. Okay, so that means my factored form is y is equal to x plus 3. Oh, wait, I'm skipping ahead here. It's not that. It's negative x squared plus 3x minus 5x plus 15. Okay, now I have to do common factors. So the first common factor, this has a negative, so I'm going to factor out the negative with it. So negative x. I have x minus 3. Okay. This has a minus 5, so I'm going to factor that out. And this will be x minus 3. My two brackets are the same. Perfect. That means I'm doing it right. So this is x minus 3 times negative x minus 5. Okay, so I factored. Once you factor, what you do is you set your y's equal to 0. Keep your two factored brackets the same, negative x minus 5. Then you use these two to solve. Okay, so I have two possible answers, either x minus 3 is equal to 0 or negative x minus 5 is equal to 0. Okay. So if x minus 3 is 0, that means x here has to be 3 to make that work out. And the other one is negative x minus 5. If negative x minus 5 is 0, that means negative x is equal to 5, which means x is actually negative 5. Okay, so please be careful with that negative over there. Alright, here's my two roots. X is 3. 1, 2, 3. X is 3 is over here. There's one dot. X is negative 5 is over here. Here's my second dot. I'm going to change colors here. Let's go green, and we're going to use green to go find vertex. Alright, so vertex is in between negative 5 and 3. What's the midpoint between negative 5 and 3? There's 8 steps to go from negative 5 to 3. 5 to get to 0, 3 more to get here. Okay, so that's 8 steps. Half of 8 is 4. So the vertex is 4 steps away from each dot. So 1, 2, 3, 4. Vertex is right there at negative 1. Okay. So vertex has a point of x equals negative 1. Perfect. So we can use our formula or our function there to go find the y. Negative of negative 1 squared minus 2 times negative 1 plus 15. Negative 1 squared is positive 1. There's a negative still in front though, so it becomes a negative 1. Negative 2 times negative 1 is plus 2. And then plus 15. Combine all that, you get 16. Okay. So my vertex is at negative 1 and 16. Okay. Without even graphing, I can already state my domain and range. My domain is going to be x, not equals. X is in the set of everything, is all real numbers, so XER. Y is also in the set of everything, but I also have a maximum. And my vertex is my maximum point here, so y has to be less than or equal to positive 16. Now let's go graph it. Negative 1 and 16 is over here. There's my dot. Okay. And just kind of roughly make a parabola from here. So it goes kind of like this. When I mark this, I'm not marking you based on how accurate your drawing is. You're drawing it by hand. I understand that. It doesn't have to be that close. And there we go. That's how we do these problems.